Hi, my name is Guang and 12 years old. For this lesson, we'll be continuing on with the techniques and applications for definite integration. For this lesson of definite integration, we have double integration d and then cosine y over y dx dy, and then d is bounded by x is equals to y squared and x is equals to y. So first, if you want to just draw the graph, what you're going to have is so over here for this part, just a reminder the fact that over here x is y squared and then x is equals to y. So for the part that x equals to y, over here it will be, so x is equals to y and then we'll also have x is equals to y squared or y is equal to square root x. Well, for this part over here, I'll explain later why I'll write it in y instead, okay? So over here, what we have for this part is basically somewhat like this. So for this part, the below part is not exactly necessary because that the area bounded is only over here. Okay, so now that we have found out how for the area bounded, we can already start. So over here, you may be wondering for this part, so supposingly you have y over here and you have the x, right? So are you supposed to integrate with respect to y first, or are we supposed to integrate with respect to x first? Well, you see over here, if you integrate with respect to y first, you actually whoops, I didn't write the function over here. X is equal to y squared, okay? And then for this part, if you integrate with respect to y first, what you're going to have is something that you cannot solve. And since you cannot solve it, then obviously you would do it with respect to x first. So when we do it with respect to x first, what we're going to have is, so for x for this part, is it hit from y to y squared? Well, over here is like this, okay? Okay, so for this part, oops, over here is from the y squared to the y. Then for what about in the y-axis? So for the y-axis over here, in which 2 points does x equals to y and x equals to y squared are the same? So one is definitely 0, y and y squared both will be 0, another will be 1. So what will happen is that for y it will be from 0 to 1, okay? So it's basically saying that the two intersecting points are 0 and 1. For y and y squared will be the same at those 2 points. So now that we have gotten this, we can continue on with and then for this part you can integrate x already. So here it's going to be x from y squared to y dy. Now that we have gotten this part, what we're going to have next is we can sub in the boundaries and you get So you have y minus y squared, which will have dy over here. So what we have for this part now will be, so we separate it into two parts. So y and y, you can simplify those two and you get cosine y dy. But what about for y squared? For y squared, what you have is y cosine y dy. So now that you do it, what will happen? So first of all, we can integrate the cosine y over here, which you will get sine y, and then from 0 to 1. But what about for this part? So over here for this, you can choose to use the integral by parts, whereas you can put this in and you get, so if you put the cosine in, it will become and then the sine is from 1 to 0, so sine 1 will be sine 1, and while sine 0 is will still be 0, so sine 0 you can just ignore it because it's equal to 0. Well, for this part over here, what we're going to have is that, so integral by parts, you have y sine y from 0 to 1, and you have this part, which is going to be plus because of the minus from integral by parts, and this minus cancelling each other out, and you get from 0 to 1 sine y dy. And now you got the sine y, you can integrate for this part. So as you can see for this, you have sine 1 minus. So when you sub it in, what you're going to get is sine 1. And if you sub in 0, it will just become 0 times 0, which is still a 0, so ignore it. But for this part, what you're going to have is, so when you integrate this, it will become a negative, right? Negative cosine from 0 to 1. So these two will minus each other out, while for this part, there will be a negative cosine 1. And for cosine 0, over here you have put an add, and it will be 1, okay? So that is basically our answer for this example over here. Now we'll be moving on to the next example, okay? Moving on, for our next example, we have double integral d e to the power of negative y squared dx dy. And then d is bounded by x equals to y equals to 2, and y-axis. So first we are going to draw our graph over here. And then we also have y. So for our first line is y equals to x as we intersect through the 0 point. And then after that, we also have our y equals to 2, whereas here is going to be t2, and we'll have and last but not least, we also had our y-axis, which was already there in the first place. So what we have over here is simply just, so our area bounded is by these three lines Okay. Alright, so for this part, so supposingly over here you can choose to integrate according to with respect to x first or with respect to y first. Well, for this part, e to the power of negative y squared, hence we had similar examples in the past and we learned that if this kind of power we cannot just integrate them. Okay, well for this what we're going to do is we're going to integrate with respect to x first. So if it's integrating with respect to x first, so the y is obviously 0 to 2, then what about the x? So the x over here is 0 to y, right? Yes. So here for our x it will be from 0 to y, while for y it will be from 0 to 2 as shown in the graph over here. Now that we have gotten this part, we can already integrate for dx, which we are going to get so over here what we're going to have for this part is, so this you can substitute inside the boundary. So if you substitute the y, here you have y e to the power of negative y squared dy, and then here we'll have and if you substitute the 0, it'll just be 0, so you can ignore it. Now that we have gotten this part, we can put the y inside and we'll have a y squared, right? But you have a half in front. But in order to actually get the same here where x you want e to the power of x dx, you can also add a negative, which you're going to get negative y squared. And when we get negative y squared, what we're going to get is that this integration will become negative half e to the power of negative y squared. Basically just the integration of e to the power of x dx. And we can substitute this inside, and when you put this over here, negative. So for this 2 squared is 4, so it becomes 2 e to the power of e to the power of 4, and then we'll also have 0, whereas if you substitute this inside, it will just become 1, and the minus over here and the negative will cancel out, and you'll have 1 over 2. And this is our answer for this example. So what we mainly use during these two examples is that we change from integrating with respect to y first to respect to x first, then we make the y part able to be integrated. Well, over here you may be wondering, well, for this part, what about special cases and all? Well, this isn't a special case, so we cannot do it. Well, that will be all for this lesson. Last but not least, thank you for your watching.